I did a little calculation in the meantime and calculated the years here now. The point is, this is 570 arc seconds in 100 years, and that is roughly 1/6 of this. So that means we have 1 degree within 600 years. And then if you want to have the full circle in 600 years, so you have to take 360 times 600, and that's roughly 200,000 years. So I missed 1 order of magnitude. So the effect, the total effect, is in 200,000 years, 1 full rotation of the ellipse in 200,000 years. And of that effect, 7%, that's roughly 7%, is 42 in 570, something like 7%. 7% is unaccounted, right? So it's a very small effect. It's a very, very small effect, right? It was certainly very difficult to measure it. It's a very small effect, and then the calculations are quite complicated. We have very small influences, and the smaller the things are, of course, the more insecure you are, because then the errors have a much more weighty influence, right? So that's the situation, and that's the situation in really advanced or frontier science, that you are really at very high accuracies and you have very delicate stuff, and the more delicate it is, the more you need your judgment, judging something and evaluating it, and then things may become pretty unclear, right? And the confidence then in this particular number is, of course, not very secure, as it's such a small effect, such difficult measurements, and so many approximations in the calculations. Okay, so that finishes this example. All right, so what I said is, and that is what I'm saying here, that incommensurability presents difficulties to theory comparison, but it does not make theory comparison impossible. As we have seen in the history of science, people made up their mind and they found arguments why they thought this theory is really the best one, and this is the one by which we now proceed. And for instance, in the case of general relativity, from 1915 on, this has been the general framework for physics, and I'll come back to general relativity in a few minutes. Okay, so this may be for you, that this may be a little surprising why I say that it's not impossible, but the point is that many people who read paradigm theory, they believed that the author of paradigm theory wanted to say that a rational theory comparison was just impossible. And he never wanted to say that. He just said, look, if you look at the history of science, then you find the phenomenon of incommensurability, and incommensurability just makes theory comparison much more delicate, right? Complicated. And you need judgment, as I tried to show you with that example, that you really need judgment. It's a tricky thing. It's not straightforward. You have to think about it and make a judgment. And it doesn't make theory comparison impossible, as some commentators, quite a few commentators in the beginning believed, because they didn't understand the theory well enough. Okay, so therefore, if you say, well, that's trivial, so forget it, fine, it's just something that you may find in the literature. Okay, so one of these effects is here, that theory comparison is so difficult, it helps explain why theory choice in the sciences is sometimes a quite lengthy process. It takes a long time. If you look at the Copernican revolution, the revolution, from I talked about it, from the geocentric to the heliocentric point of view, the sun in the center of the earth in the center of the world and the sun in the center of the world, that was a process that took roughly 150 years. 150 years. Because you had this sort of incommensurability stuff and it was difficult to evaluate. And also, I told you that the question of the acceptance of Bohr's model, the atomic model, which seems so smashingly successful, it also took 2 years. People couldn't make up their mind whether the whole game that Bohr proposed, calculating properties of atoms, was just, playing around with numbers with no physical significance. People didn't believe it. They said, that's very funny, it's inconsistent and it somehow works, but shall we take it seriously? It's not clear. So that explains why theory choice in science is sometimes a lengthy process, which you cannot understand if you have simply data, fixed data, and you evaluate the theories according to the data, because the decision is quick. Like most decisions, I'm told, in experimental chemistry are fairly quick. If you have a doubt something, you set up an experiment and you make the experiment, you run the experiment, and the disagreement is dissolved because you can simply decide it on the basis of experiments in experimental chemistry in many cases. But when it comes to the larger theories like quantum mechanics, gravitation, and so on and so forth, the situation becomes more complicated. Okay. Now, the thing that is perhaps interesting for you is that incommensurability does not only apply to the relationship between normal science traditions or fundamental science, but also to the relationships between the schools of pre-normal science. Okay, so don't worry about it, schools about normal science. Here's the point that may be of interest to you, but in somewhat modified form, it concerns also the relationships between different cultures. And that's, of course, because you come basically from other cultures than the Western cultures. Your home culture, at least of most of you, is different from the one that you find here in the West, although your home countries, most of them moving towards the West to some degree. But if you look, say, to your grandparents, and one of the very interesting examples is healing, is medicine, healing procedures. If you imagine what your grandparents think about efficient way of healings, as long as they are not influenced by the Western medical tradition, but the traditions that are in your home country, whichever it is, right? If you come from Africa, for instance, or Asia, then you have traditions there of healing which are very different from the Western traditions. And if you want to talk to your grandmother and explain to her why you believe in the Western tradition of healing and what the arguments are, if you do, I don't know whether you do, but if you want to compare the Western tradition of medicine and of healing, and then you ask your grandmother if she's a traditional woman, and when she talks about healing, what is relevant to her, and what to her are relevant data, even if she comes from a tradition that's very, very alien to the Western tradition, she usually has arguments. She just doesn't say, yes, I do that, period. But she can present arguments from the other tradition. But if you want to evaluate the arguments from that tradition in terms of the Western tradition, you don't understand a word, right? It's when it comes, say, to voodoo. You can't understand voodoo in Western terms at all, right? In the same way as you can't understand from the point of view of voodoo. I'm not telling you buy voodoo, it's the best to do. I'm not saying that. I'm simply saying if you compare these traditions, if you try to understand from the voodoo point of view, say some things that happen in your life which are unexplainable, and then you say, well, voodoo gives me a framework how to explain that. If you want to understand what Western medicine does in terms of voodoo, there is no way. You can't reproduce what Western medicine does in terms of voodoo. It's incommensurable. In the same way, you can't explain and describe what voodoo does in terms of Western medicine. You can't translate these frameworks. It's just impossible. And voodoo is a more extreme example. You can also have, say, things of herbal healing, where Western medicine says perhaps, well, we don't understand, we don't know what the content of these herbs are, why are they healing, we don't believe it, why is it important to have these circumstances, which may be part of a tradition. So the point is that I'm trying to make, it's not that the importance is not these particular examples, whether it's voodoo or not, you may like or dislike it, that's not my point. My point is when it comes to a relationship between different cultures, right? Say the Western scientific culture and cultures in your home country, whether it concerns healing or other things, relationships, description of relationships, and so on. The point is that the difficulties in making contact between these different cultures, that is usually a case of incommensurability. You do not have a common measure. You don't have a fixed point that's valid in both cultures. Right? Such that you can say, okay, I can compare them with respect to this common measure. It simply doesn't exist. And that explains, once you work that out in more detail, whatever the particular situation is, that explains why it is so difficult to make contact between different cultures. And I guess for some of you, it's a rather painful process to adapt here to some degree to the Western culture. Because it's something where you have other parts from your own home culture which you cannot translate in here, and you cannot really evaluate from the point of view of Western culture. On the other hand, there are things in Western culture that may be alien to you somehow. You say, well, it's a successful science, therefore, and I'm a scientist, so it's better that I stick to them. But you can't really, make a solid bridge between the parts of yourself, right? And that is because of incommensurability. There is no common measure. The concepts are fundamentally different between different cultures. The ideas what is relevant data is really different. If you talk to someone why he thinks here is a case from which you see there is a voodoo influence, he comes or she may come with data which you say, come on, they're completely irrelevant. And the other person will say, no, you're wrong. They are relevant. They show this is the influence of that and that practice of that person, right? You say, no, they're absolutely irrelevant data. You have the same effect here with the data. You cannot translate the concepts, and also the values by which you evaluate are very different. When you evaluate a certain tradition, and then you think that from a certain local tradition, indigenous tradition, they have values to show what is important and what is unimportant, that's very different from what is, from the point of view of the Western culture and Western science, what is important and what is unimportant. So you're lacking a common basis of values in order to evaluate. And therefore, I think this topic of incommensurability, it's much more relevant and important than just for the explanation of the history of science and for paradigm theory. I think it's something that's very important in our globalizing world, of which you are a part. You are really an indicator for globalization. You come to this country in order to learn Western science and Western engineering, and you have then to deal with what you bring with you from your home country to this Western culture, and then we have this clash of cultures, and it's happening inside you, and of course inside also your families, when you come home and tell them what the Western world is like, as far as they don't know about it by television and so on and so forth. At any rate, so I think this is the incommensurability is a very important insight, not only for science itself, but also for the larger picture when we talk about, in a globalizing world, about the relationship and the difficulties of understanding different cultures. So therefore, I put quite some effort in that topic, because I thought it might be also interesting for you in a wider context of just your studies, but of being here in Germany and having to live here. Okay. So, was this somewhat understandable? Okay. Helpful, perhaps? Well, think about it. Okay. So, we come now to the next step. And that step concerns now the question that I already mentioned a few weeks ago. That is the question of the relationship between these philosophies of science that I discussed formally, namely inductivism and deductivism, which are normative philosophies of science, as I told you. They set up norms how good science should be practiced. In contrast, paradigm theory, as I announced earlier, paradigm theory is a descriptive philosophy of science. It presents a generalized description of how science develops. And the point is now, the problem is now, what do we do with the tension between a normative philosophy of science, like deductivism, and a descriptive philosophy of science, like paradigm theory? And let us see where such tension arises. And the most important tension between the normative philosophies of science, inductivism and deductivism, and the descriptive paradigm theory concerns normal science. Right? In paradigm theory, normal science is a very important part of science. You stick to a paradigm, you have your paradigmatic solutions, and you model your scientific practice after these paradigmatic solutions. And the tension is this, that from the point of view of the normative philosophies, normal science is a bad practice of science because of its quasi-dogmatic element. The quasi-dogmatic element, I told you, is that you have a practice of science like puzzle solving, in which you do not question the basic rules of normal science. Right? This is the point. You do not question them at all. They are not tested. You are simply applying them. And if you look at that, especially from the point of view of deductivism, then this is just bad science, because you are not testing these rules. And what deductivism tells you is that you are not allowed to use something which you have not continuously, or which you are not continuously testing, because you must always devise more and more tests in order to possibly falsify them. And you don't do that in normal science. And that's why I also use the term quasi-dogmatic, because the quasi-dogmatic highlights this difference to what deductivism says. So from the point of view of deductivism, normal science is a bad practice, right? It's not a good practice. Now the question is what to do. Wow, okay. Now, here is the question that arises, namely whether the normative philosophies are right, in which case most of modern science is indeed bad science, or whether the normative philosophies are wrong in that respect, in which case normative science is a good scientific practice. Well, both could be wrong. Both the philosophies could be wrong, and it could be a bad practice. But let's not assume this worst case, right? So, I guess the bottom of your heart will say, of course, science is right and the philosophers are crazy, but that's not an argument, right, from the bottom of your heart. It's not an argument. Let's look whether we find an argument, right? Okay. So we have here a situation that is exactly the sort of situation that I talked about earlier, not today, but some weeks ago, when you have a norm and you have a certain practice, and you have a disagreement between the norm and the practice. It's not clear what is wrong. The norm could be idiotic, or the practice could be bad, right? Or both things could be bad. I exemplified that if you had a speed limit in Hanover of 5 kilometers per hour for every car, 5 kilometers per hour, and everyone would go 13, say, or 15, right? Then, of course, it would be in disagreement with the norm. But everyone would say, well, this norm is idiotic. 5 kilometers per hour for cars in a city, it's idiotic. It doesn't make sense. So the norm is bad. But if you have a speed limit, say, of 50, as we have in Hanover, and some people go 60 or 70, then people would say those who do 70 kilometers an hour are wrong. They're making a mistake. It's bad to drive that fast. It's too dangerous in a city. There are pedestrians, and we have this rule of 50, and it's a good rule, right? So it's always the question when you have a difference, a tension between norms and the practice, that it is not clear what is wrong, right? It could be the norms, it could be the practice. That's our situation here. I know that from the bottom of your hearts you say the scientists are right. If there's a tension between scientists and philosophers, it's clear that the philosophers are wrong, the scientists are right. Why? Because I'm a scientist. That's of course not a particularly good argument, but I know that, but let's go about that a little more carefully. Now, paradigm theory defends the practice of normal science. Paradigm theory says, yes, normal science is a good scientific practice, and paradigm theory says, I can show why normal science is a good scientific practice and why the normative philosophies of science are wrong, right? So they give an argument, or paradigm theory gives an argument, not just a gut feeling that you say, I know who's right, it's me, okay? So, and it does it in the following way. Paradigm theory defends the practice of normal science by showing that this practice serves vital functions for the goal of science, right? What is the goal of science? Well, the goal of science is, abstractly speaking, fairly simple. It's knowledge production. Science must produce scientific knowledge. That's its whole aim of that, right? Like the industry, say the plant industry is supposed to produce good plants, right? And science is supposed to produce good scientific knowledge. So, paradigm theory defends the practice of normal science and says, look, normal science serves the goal of science, namely, it produces wonderful knowledge, and that normal science is a reasonable scientific practice, and consequently, that the normative philosophies of science are wrong in this respect, right? So, that's the strategy that paradigm theory develops. It says normal science serves vital functions. It's a reasonable scientific practice. It's good the way they do it, and consequently that the normative philosophies of science that say that normal science is bad must be wrong. Right? That's the strategy. And here is how it works. The argument runs as follows. This is just the structure of the argument, right? It doesn't fill in the details, and I'm filling in now the details. You know, the deductivism says, no, normal science is bad, it's quasi-dogmatic, it doesn't continue testing. So because it doesn't continue testing, we say it's a bad science, a bad form of science. And paradigm theory said, look, no, look a little closer. Look what are the achievements of normal science. It serves vital functions for the goal of science, it's a reasonable practice, and therefore the normative philosophies are wrong, and the argument runs like that. And that is probably no surprise for you, because I already hinted at the problems that the normative philosophies of science run into it, namely this question, what was missing in deductivism especially, namely a principle for the temporary acceptance of certain theories. I said that deductivism is self-destroying in effect because it has no way of stopping testing, and the testing is infinite, right? There's no way of stopping that. And once you describe paradigm theory now in a way that you see that it provides this criterion when you are allowed to stop testing, then you understand why it's a reasonable practice, because you need that, right? The quasi-dogmatic element provides the principle which was missing, especially in deductivism, a principle for the perhaps only temporary acceptance of hypotheses that allow for temporarily halting tests, right? That is what normal science licenses you. It says, once you have reached the stage of normal science, then you are allowed to stop testing, and it's reasonable to do so. Why? Because once you encounter difficulties with your normal science, with your theory, they are not immediately taken as indicators of its failure in principle, but exposing the incapability of the respective scientists. That's what I told you. Once you have anomalies in normal science, which happen all the time, a problem you couldn't solve, then it wasn't immediately channeled towards the guiding theory that you say, oh, the theory is a disaster, but you rather say, oh, this scientist is a disaster. He or she cannot solve the problem. It's not a problem of that theory. Now, why is this good? Well, if you give up a theory because of one problem you cannot solve, you never find out what the real potential of the theory is, right? If you look at Darwinism, and in Darwinism, back in 1871, I think it was, when Darwin discovered this problem of the sex ratio, right? The one-to-one ratio between the sexes in biological species. And Darwin said, I cannot solve the problem, right? I don't know how to solve the problem. According to deductivism, people should have given up Darwinism, right? It was a falsification of Darwinism, right? People should have given it up. And then Darwinism would have been thrown away, and people would have started anew. Now, the point is that with the sex ratios, I looked it up in the meantime, that the first serious work on sex ratios was then done in the 1930s, 50, 60 years later, right? People knew there was a problem, they knew they can't solve it, but they didn't give up Darwinism, which was absolutely right that they didn't give up Darwinism, because it is a problem that wasn't solvable at that time, but it was solvable later. And people, again, you see here, had the right judgment. It's a question of judgment. You look at the problem of the sex ratio, you look at Darwinian theory, you look at what Darwinian theory is able to solve, and then you say, well, sooner or later we will probably solve the problem of the sex ratio, right? That's the same way coming back here. You have this left, 42 arc seconds per century. You have solved 93%. And then you say, reasonably, we will come back to that, and sooner or later we will solve it, right? In this particular case, the judgment was wrong, but it was a good judgment. It happens to be wrong. In the case of Darwin, you had this anomaly. People also said this is not a catastrophe, we will solve it sooner or later. And it took then 60 or even 80 years until it was really solved. So you see that it is reasonable not to give up a theory immediately once you encounter difficulties. It's just, it's a question of time. You have to find your way. There are no really hard arguments, right? If someone had said in 1870, okay, I don't believe in Darwinism at all because it doesn't give the right sex ratios, I do something else, well, fine, this person would have ruined his life as a scientist. He or she would have done something else, nobody would have taken attention. He or she would have done whatever it is, but outside of the Darwinian paradigm, people would have said, what do you do? I'm not interested, right? And if that person had instead worked on another problem within the Darwinian tradition, she or he would have become perhaps a famous scientist doing good work, interesting work. So it's a question of judgment. It's quite delicate. Science is can be a quite delicate thing, especially when you encounter anomalies. And in that particular case, it is useful not to take something like that or the sex ratio as a falsifying instance, as something which shows that your theory is false and give up the theory, because then you can never find out what the real potential of the theory is. And that's a very, very strong argument for which you have thousands of examples in the history of science. You must find out how good a theory is, because the really good theories that were invented in the history of science, like classical physics or Darwinian theory, or the theory of chemical bonds, or whatever it is, the really good theories have an immense potential. It's incredible how strong they are. It's a miracle how strong they are. They may not be right in the end, but first of all, you have to understand what these theories are able to do. And they are extremely strong. That is really something you can see in the history of science, and you want to know what the real potential of a theory is before you give it up. So you better stick to a good theory as long as possible. And only give it up when it's absolutely unavoidable, right? Only then, and not earlier. Work with it as hard as you can, and only when it comes to the point where you say, there is absolutely no way. The very best people in the world in this area have worked on it, and we can't see any way how to improve the theory. That was the situation, as I told you, from 1922 on with Bohr's model, that people said, look, we do not get any results any longer as hard as we can work as hard as we want. It just doesn't give any more results. It's just over. And then people said, okay, let's give it up. Okay? But they worked very hard to get out the potential, and that is very important. And this is what is exactly what the quasi-dogmatic element of normal science delivers to the scientist. It says, stick to the theory and work with it. Come on, don't give up. There are always possibilities why something goes wrong. It's always possibilities why these 42 arc seconds cannot be explained. There are many, many possibilities why the theory can't do it. It's not important. We don't know what it is, but don't give up the theory because of that. It just doesn't make sense, right? And here Darwin's sex ratios is a wonderful example for that. So it has often, that's what I said already, it has often happened in the history of science that problems could eventually be solved in the existing research framework. And you can only get at that if you stick to the theory long enough, right? What exactly long enough means is a difficult story again, because that's the question once you judge an anomaly as a significant anomaly. And that's a question of judgment again, for which again there is no strict criteria. But that is the point that is important here. The further thing is, the longer you work with an anomaly that may become significant, for instance, this one here, or that one here, that became a significant anomaly. If you work for a long time on a significant anomaly within the old framework, right, then you may get a deeper understanding of where exactly the failure of the old theory lies. Right? You must understand at what point exactly your old theory collapses and doesn't work any longer. Because the better you understand that failure of the old theory, the more hints you get what the new theory must accomplish, right? So the better you understand the failure, the better chances you have for the invention of a new theory. This may prove extremely important for the invention of the alternative, right? So that's the same in relationships, right? Once you have a relationship and the relationship doesn't work for whatever reason, and it's sometimes quite useful to understand what an idiot you are yourself, right? And you understand that why your partner thinks you are an idiot, because then you get the chance of improving yourself, right? And avoiding this mistake in your next relationship. So it's useful to understand what went wrong, right? That's very important. So why do people say after you have an air crash, right? Then why is it so important to say this is what not a crash, but with this engine of the A380, with this new airplane from Airbus? Why do people analyze exactly what went wrong with this engine? Why? Very simple. Because understanding the mistake helps you to avoid it in the future. Right? That's exactly the same. So they are analyzing that every air crash is analyzed to an unbelievable degree. Right? They fish out of the water when it was a water air crash. They fish out all the parts of the airplane and put it together in huge holes to put the whole airplane together again with all the remainders, just to analyze exactly what the mistake was, what the source of the failure was. Because from the source of the failure, you always learn something for the improvement. And that's exactly the same in social relationships, you know, people being together, as in technology, and this is the same here. You must understand what goes wrong. And therefore, working on even a significant anomaly in the old framework reveals something about the weaknesses of the old framework from which you may learn, oh, that must be avoided in the new theory. And you only learn that if you do it in the framework of the old theory. So paradigm theory is very, very sophisticated in that respect. It's sophisticated in the sense that the quasi-dogmatic element brings people to fully exploiting the potential of the old theory, but not only that, at the same time, when you work in the old framework on a significant anomaly, you get enough hints also for the new theory. So it's a double, it looks in both sides. It looks in fully realizing the potential of the old theory, and if the old theory has to be replaced by a new theory, you're getting hints of things that the new theory, of features of the new theory, by analyzing the mistakes of the old theory. So, and there you need some sort of pressure to do so, and that's the quasi-dogmatic element. The quasi-dogmatic element simply tells you, don't give up too early. Stick to the old theory. Usually it's your mistake, right? Not the theory's mistake. It's usually your mistake. You're too stupid. You choose the wrong problem, right? You don't have the ability to solve the stuff. It's your fault, not the theory's fault. And that's a very good strategy for these two reasons, both finding out, getting the full potential of the old theory and also getting hints at the new theory. And you see immediately if you gave up this principle of the quasi-dogmatic element, without it for the acceptance of theory, scientists would tend to jump from one theory to the next without ever knowing the real strength and the real weaknesses of the theory. If, as I said, if the guy in 1871 would have said, oh, Darwinian theory can't explain the sex ratios, away with it, let's take something new. And he or she would have invented something else, and then after the first difficulty say, oh, it doesn't solve this problem, get away with it. And they would jump from one theory, not really developing anything in any great detail and any depth. And the quasi-dogmatic element in paradigm theory just does that. Thus, the quasi-dogmatic element of normal science serves the aim of science, and it is reasonable. And that's the argument against the normative philosophies of science. So you develop, out of the descriptive philosophy of science, you develop an argument to say that, to argue for the unreasonableness of the normative philosophies of science about the continuous testing. And that was the aim of paradigm theory here. And the historical remark we'll have to wait until the next session, which will be in 1 week, the last session before the Christmas break. And I wish you 7 wonderful days until that.